My name is Tuinman. I am a lead engineer for HEXION, working within the Technology Engineering and Projects Department. And I'm presenting you today two presentations, one on the case study 6 and also on the work package 6, which we are leading. Case study and work package 6 focus on the demonstration of closed loop water and materials recovery in the industrial section. So we HEXION, we are an industrial company, and we are excited to explore this topic. I will first give you an overview of the case study, and then go a little bit deeper into the two different demos within this case study. So the case study overview, and this you should recognize from the grant agreement. We have two industries that we are looking at. One is the epoxy resins industry, of which HEXION is a part in the Netherlands. And the other one is the sugar industry in India. So two very different cases. What the idea is of the demo units is that we will have transportable units in 40-foot containers that we can assemble in different settings to achieve appropriate water treatment and water recovery and materials recovery for different situations within the industrial industry. The capacities for these units will vary between 150 liters per hour and 2 cubic meters per hour, also depending on the tests that are going on right now, looking at residence times and the different treatments needed. So we're focusing in this case also on something a little bit special, which is the idea of chemical leasing. I will explain that a bit more when we go to the first demonstration location. So we have the epoxy resins industry in the Netherlands, which has the HEXION plant. HEXION is located within the chlorine cluster in the Rotterdam harbor area. We consume their chlorine and caustic soda, which we receive from Nourion, and we deliver back into the grid HCl. We have several industrial processes on our site producing precursors like ECH, but then also the epoxy resins, acetic acid, and derivatives. We have, as I said, a unit also to recover some HCl, and we have several furnaces. We are also heavily intertwined with Shell. So all our wastewater goes to the Shell biological wastewater treatment. And we use a large part of our steam comes from Shell, as well as refinery gas to fuel our furnaces. Now, I promised I would say something about the concept of chemical leasing. As I said, we're receiving sodium hydroxide and chlorine from Nourion, and part of it ends up as HCl, part of it goes into our byproducts, but also a large part of it actually ends up as salts, sodium chloride salts, for instance, in our wastewater. And the idea is that this sodium chloride is the exact sodium chloride that Nourion used to make the caustic and the chlorine through their electrolysis process. So if we can refine these streams and recover this sodium chloride, give it back to Nourion, they can again begin the cycle of applying electrolysis and producing caustic and chlorine to deliver back to us. And then you come into a concept of chemical leasing rather than buying chemicals and sending them to ultimately to the surface water. Now, the idea for a treatment train to achieve this is to take a little bit of the wastewater from our plant 2 and apply several different techniques. One is high pressure oxidization, supplied by the company KVT, where oxygen is used to destroy the carbon, the organics in the wastewater and convert them to CO2. This is done with a catalyst, which is then needs to be recovered. And then we have a salt stream, a salt waste stream, a brine stream free of organic content, or at least almost free of organic content. And then the next step could be either multiple effect distillation or a crystallizer. We have to figure this out, what works best in our case, and what are the limitations of these different techniques, to ultimately get to a concentration that is high enough to pass on to an electrolyzer. And then that part could be done, for instance, by Nourion. So yeah, I'm really excited about this concept. We are currently working out what this treatment train could look like. And this is the main focus for the demonstration at HEXION Pernis in the Netherlands. Now the replication case, something completely different. The Indian sugar industry. We have contact there with the Vasandara Sugar Institute, which should help us get into contact with a plant where we can test also this same equipment, possibly in a different setting, because they have very different processes, of course. You have the sugar mills, you have the distillery, then there is a lot of anaerobic digestion. A lot of the biomass is then incinerated to, again, generate steam. They already apply largely zero liquid discharge. So the idea here is that with the different effluent streams that they have, could we use these techniques to look at going to a higher level of reuse? So recovering pure water that can be reused within the process and converting organic matter, for instance, with the Comera techniques, to go into bioplastics. So I think that is the main focus for case study 6. A lot of partners involved, really excited to work with everyone. So thank you for that. And I will now switch to the second part of my presentation, which focuses on the details of the work package. If you can bear with me as I share my screen. And I will try to get to the first page. I am having a bit of a slow connection at the moment, I think, but we will get there. So as I said, also the work package that goes with the case study. HEXION is leading the work package 6, together with the partners that you just saw. I will first give you an overview of work package 6, then go into a little bit more detail on the description of the different tasks, focus mainly on the first year of planning, and also talk a little bit about the interlinkages with the other work packages and what we see as risks and possible mitigations. So as I said, the objective of this work package is to demonstrate the repeated use of water and materials, in our case chlorine and caustic, through a closed loop system. And that's done in the industrial environment. The concept of chemical leasing is the idea behind this. But we also have some KPIs that, yeah, of course, chemical leasing is not a goal in itself. The idea is that we're also making some benefits here. So that's what we focus on with our KPIs. We hope to reduce the use of fresh water with 70%, because we're actually sending the sodium chloride back with a lot of clean water to Nourion, which means they have to use less fresh water. We also aim that the energy requirements for these processes are covered for a large part using waste heat. And we hope to achieve recycling of the chlorine and sodium streams over 90%. So not a lot of bleeds needed, but really recover the bulk of it. And the month to achieve this would be month 42. So here you see outlined the different deliverables for the work package. What we're currently focusing on is really the bench scale tests. So we will report out on those in month 8. And then next, after that, becomes the engineering drawings for the demonstration unit from KVT, which is the high pressure oxidization unit. Then we have the operating manual, of course, for that unit. And other deliverables focus on report outs of the demonstration and other intermediate reports to make sure that we can, along the way, share our results with the other work packages, as they can be also very relevant for them. So as for milestones, the biggest milestone is the startup of our demonstration unit. It will actually start up at the end of 2021. But as a milestone, we have set month 20. The idea is that we install the unit and we will need a few months to optimize it in place. So we aim that it is running smoothly in month 20. We already have a location in mind at our plant in Pernis. You can see here. So this should be able to house the 2 to 3 40-foot containers containing the different units of the treatment train. Here you also see the process scheme for the high pressure oxidization. In this process, already a lot of heat is generated and recovered. So that is also where a large part of the heat recovery and the waste heat usage is coming from. And then you see also there is the catalyst recovery step, which ultimately should purify the brine for it to be good enough for the application of electrolysis. Then the second demonstration is, as I said, within the Indian sugar industry. That comes after. So once we've dismantled the setup in HEXION, the equipment is available to transport to a second location, which is yet to be identified. Very detailed description of the tasks coming from the grant agreement. I think what is important to mention is that we are working now very much on task 6.1, designing the treatment system. For this, we are doing a lot of bench scale tests using very nice equipment from a lot of institutions. And that is what we are focusing on currently. As I said, a lot of bench scale testing. Here you see a nice picture of the setup at KVT. They have a bench scale high pressure oxidization unit, which is fully automated and can run 24 hours a day. We've already sent 50 liters of our wastewater to KVT, and they will be testing with this in the coming weeks, I think week 48. And this should give a lot of input on the design of the final demonstration unit. They can use this equipment to test different temperatures, residence times, oxygen flow rates, all to optimize the breakdown of the TOC. Another location where there is a lot of nice testing equipment is the University of Athens. So they have a multiple effect distillation unit available, as well as a crystallizer. So we plan to do tests with these as well, really to find out what is the best way to concentrate the brine to a concentration that is closer to what is needed for electrolysis. And this is a region of concentration that has not been explored yet within their previous projects. So I think it is interesting for everyone to work on this. And then Euracat has a nice membrane distillation unit. We are thinking to also do some tests here to look at the possibilities of separating out solvents from our brine. We have also brine streams that are more upstream in our process, but they contain a lot of solvent still. So the idea is that membranes could be a solution to separate that, which would then mean that we would not have to do a concentration step. So this can also be a very interesting technique, which at least we want to test on a bench scale. As I said, a little bit more focus on the first year planning. So in April, we hope to report out on the lab and the bench scale tests. And then in August, the drawings for the demo unit should be ready. The way we keep track of our progress and interlinkages with other work packages is through a weekly online meeting. I think so far we have had already 4 or 5 of the meetings with the different work package partners present. So that's going really well. And we're using also a project file similar to what Dimitris was showing in his presentation, I think for work package 2 and 3. To manage our actions and deliverables. Interlinkages with other work packages. Of course, work package 6, we're part of the executive board. So there we have our link with the project management. We link with work package 3, especially case study 1, for some of the equipment that they are using there in their demonstrations, and that we also hope to use as part of our case study 6 demos. Then we have work package 7, focusing on the visualization of some of the KPIs that we are hoping to achieve. And then I think very importantly, coming back to the concept of chemical leasing, within work package 9, we would like to explore what a business model for this chemical leasing could look like. If we bring back sodium chloride to Nouryon, and they in turn again make caustic and chlorine out of it, what would this look like if we make a business model around this? And we would like to explore this, of course, first of all with Nouryon, who are also part of this water mining project, but also with one of the other entities, either within the chlorine cluster or within the Rotterdam industrial cluster. Risk and mitigation measures. We talked about this within the team. So in our weekly meeting, we discussed what are some of the risks that we see. I think one of the main risks is that we, somewhere along the lines, encounter delays. So for instance, delays on the startup of the unit due to the fact that we have long lead items for special materials like titanium and high pressure equipment that are used in the high pressure oxidization unit. As a mitigation, we have said that we want to fix the capacity and the size of the high pressure oxidization demo unit as early as we can. So after the tests in week 48 are finished, by the end of this year, we would like to fix the capacity for this unit. Other risks that we see are delays on transporting, especially between the different case studies. If we go outside of the EU, for instance, to India, there, I think all we can do is just really incorporate sufficient time for this in planning and engage the right people that can help with this. Then another, unfortunate risk is that we have delays due to COVID-19. The idea for the demonstration is that the first couple of months, KVT will be present at our site to operate the demo unit. If our respective countries, so the Netherlands and Austria, have at that moment rules in place that we cannot travel or that we have to quarantine when we travel, that might become a little bit more difficult. So this we also have to follow in detail and plan for whatever measures are applicable at that time. I think that was the last of it. So I'm very curious to see if you have any questions. But for now, thank you.